Hello Algebra 2 students, this video will review graphing rational functions. The first two questions are examples of transformations. They're transformations of the parent function y equals 1 over x. And you'll remember that anything that happens to the x happens inversely, so x minus 2 will actually shift you to the right 2. The plus 1 is going to shift up 1. And then the 5 on top is going to create a stretch of 5, a vertical stretch. Of 5. So remember that for y equals 1 over x, your asymptotes start on the axes. Your horizontal starts at y equals 0, and then your vertical starts at x equals 0. So your vertical asymptote was at x equals 0, and it shifted right 2, so now it's at x equals 2. Your horizontal asymptote was at y equals 0, and it shifted up 1, so now it's at y equals 1. Your domain is going to be everything except for that vertical asymptote, so we have to leave this number out. So to leave it out, we write from negative infinity to 2. And then right after 2, we pick up again and go to positive infinity. And then using the parentheses, we'll leave that number out. Your range is going to be all of the numbers except your horizontal asymptote at 1. So it's going to be negative infinity to 1 and 1 to infinity. All right, we're going to find your intercepts algebraically. So to find your x-intercept, you make y0, and that's just a little bit of work. We're going to do our best to fit this in here somewhere. So let me just use this space over here. To find my x-intercept, I need to write 0 equals 5 over x minus 2 plus 1. The next step is to subtract 1 from both sides, and that will give me negative 1 equals 5 over x minus 2. And then to get rid of this denominator, we're going to multiply both sides by x minus 2. So on the left, I'll have negative 1 times x minus 2. And on the right, I have 5 over x minus 2 times x minus 2, and those cancel out. Your negative 1 can distribute, so I get negative 1x. Negative times negative is positive. And then I solve for x by subtracting 2 from both sides, and then dividing by negative 1. And x equals negative 3. So that was a lot of steps to find your x-intercept. You're going to put negative 3 for the x, and we put 0 for the y. Finding the y-intercept is a little bit easier because we're going to put 0 for the x this time. So maybe I'll do that work up here. For my y-intercept, I have 5 over 0 minus 2 plus 1. And I can use the calculator to help with this one. So 0 minus 2 is negative 2. So it's going to be 5 divided by negative 2 plus 1. And let's use the calculator to see what we get. All right, so it was 5 divided by, remember the negative sign is different from the minus sign, negative 2, and then plus 1. All right, so I get negative 1.5. That makes sense. All right, so my y-intercept, I put 0 for the x, and I got negative 1.5 for the y. All right, remember that when you have a rational function, if it has a horizontal asymptote, the end behavior is the horizontal asymptote. So at both ends, the y is going to approach 1. So as x goes to infinity, y goes to 1, and as x goes to infinity, that should be negative infinity, y also goes to 1. All right, the next one should be done in the same way, and if you weren't sure how to do this first one and you watched the video, try to do the next one before watching the video. All right, so this time we have x plus 2, and since the x's transform inversely, we're going to shift left 2. The minus 3 is going to shift us down 3. And since we just have a 1 on top, multiplying by 1 does not stretch anything, so it's just, there's no stretch there. There's also no reflection. If it was negative, it would have reflected. All right, so my vertical asymptote is going to be an x equals, horizontal is a y equals, and I had started at x equals 0 and I shifted left 2, so I'm going to be at x equals negative 2. My horizontal had been at y equals 0 and it shifted down 3, and so it's going to be at y equals negative 3. My domain is everything except for my my vertical asymptote at x equals negative 2. So negative infinity to negative 2 and negative 2 to infinity. My range is everything except for when y is negative 3. So it's negative infinity to negative 3 and negative 3 to infinity. All right, the x and y intercept are going to take a little bit of work. So let's try using the space on the side here. There we go. To find my x-intercept, I make y 0. Remember that g of x is a fancy way of writing y. So I have 0 equals 1 over x plus 2 minus 3. And I'm going to add 3 to both sides. And 3 equals 1 over x plus 2. And then I'm going to multiply by x plus 2 on both sides, which will cancel out this denominator. The 3 has to distribute to the x plus 2, so 3 times x is 3x, and 3 times 2 is 6. These canceled out, so we just have 1. And you want to continue solving for x by subtracting the 6. 3x equals negative 5, and then dividing by 3, and we get x equals negative 5 thirds. So my x-intercept will be negative 5 thirds, comma 0. All right, for my y-intercept, I'm going to make the x 0. And so I'm going to do that over here, I think. Let's save this space for end behavior, and let's use this space for y-intercept. Y-intercept, y equals 1 over 0 plus 2 minus 3. So y equals 1/2 minus 3. And you can use a calculator if you want, but that should be negative 2.5, which would be negative 2.5. So we put 0 for the x, and we got negative 2.5 for the y. Remember that your end behavior is your horizontal asymptote. As x goes to infinity, y goes to negative 3. As x goes to negative infinity, y also goes to negative 3. The same on both sides. All right. The next one we're going to graph. And we're going to start by factoring this denominator. So we need numbers that multiply to negative 24 and add to negative 2. To get the x squared, it's just x times x. And to get the negative 24, we're going to do negative 6 times positive 4. All right, so now I have x minus 6 on the top and the bottom, and they're going to cancel out and create a whole. My reduced function is going to be y equals 1 over x plus 4. So the canceled out factor creates the whole. I'm going to set it equal to 0. Here, let's keep that over here. I'm going to set my canceled out factor equal to 0 to find the x coordinate of the whole. So the x-coordinate is 6. Then you substitute this back into your simplified fraction, and I'm going to do 1 over 6 plus 4. Y equals 1 over 6 plus 4, which is 1/10. It's pretty small. All right, vertical asymptotes. So we are no longer doing transformations. Vertical asymptotes are just going to be anything that makes your denominator 0. So here's my simplified denominator, x plus 4. And so for my vertical asymptote, I need to write x plus 4 equals 0. So remember that your denominator cannot equal 0, so anything that makes your denominator 0 creates a vertical asymptote. Subtract the 4, and we get x equals -4. It is very important that you do not just write -4 because this is the equation of an asymptote. And you could graph this. Actually, the vertical asymptote is not easily graphed in your graphing calculator, but if you wanted to pull out Desmos for this one thing to look at it, you could. If you graph x equals -4, you'll see that it makes a vertical line where x is -4, right here. Okay. Your horizontal asymptote depends on if you have a bigger degree on the top or the bottom. The degree is the exponent of x, and it's going to be the biggest exponent of x. On the top, there are no x's, so the degree is 0. And on the bottom, the degree is 1. Whenever you have a bigger degree on the bottom, your horizontal asymptote is y equals 0. So it's going to be right here, y equals 0. Okay, I'm going to skip domain and range until I have my whole graph down. I'm going to find my intercepts. So to find my x-intercept, I make y0. So x-intercept 0 over here, and use your simplified fraction. 0 equals 1 over x plus 4. And then if I multiply both sides by x plus 4, I get 0 equals 1, which doesn't make any sense. So then I look at the x-axis and I realize, oh, there's an asymptote there. So because there's an asymptote, it must not touch the x-axis at all. Also because this isn't making any sense. So I have no x-intercept. I can find a y-intercept by making x 0. So y equals 1 over 0 plus 4, which is 1/4. So I've got 0 for my x and 1/4 for my y. I do know what the end behavior is because it's the horizontal asymptote, but I might as well wait till I draw my graph to get this. So I can graph my y-intercept at 0, 1/4. It's right here. And I want to graph also the whole at 6, 1/10. So 0, 1/4 was here, 6, 3, 4, 5, 6, 1/10. It's going to be really small. It's kind of hard because I drew my asymptote a little bit higher, but I'm going to say it's about there. Okay, so that's probably enough points, but maybe I'll put another point on anyway. I'm going to graph this in my graphing calculator and try to get a few more points to make this graph. Okay, so on your calculator, you're going to press y equals, and you're going to put in, you could put in the original function. It would need more parentheses around your numerator and denominator, but the simplified function should work for what we're going to do here. So we're going to try to find a few more points. If you want to look at the graph, you can press graph. Sometimes another student may have messed up the settings on the calculator you're using, and you would need to go to zoom and then standard, which is 6. And other things can happen too with your graph, just depending on who used it last. You could always reset your memory too if you just think that the settings are all off, and you can do that with second plus 7, 1, 2. But most times if you press graph, you can look at it. In this case, we don't even need to look at the graph, we just need some points on the graph, and so that would be second graph because it's going to give us this table. I want some numbers that are going to be to the left of my asymptote, so those are going to be smaller than -4. Notice that it says error here because that's where the asymptote is. So I could try graphing -6, -0.5, -5, -1. So -6, -0.5, and -5, -1. And that's enough to just get an idea because we know that the branch is going to get close to the asymptotes. And so we can sketch it like that. Over here I have this one and this one. Maybe I want to get the point at like -3 or -2. So let's go back and look at the calculator again. So I have -3, 1 and -2.5. Those should be good points. -3, 1, -2.5. And those are going to be good points for us so that we can sketch this in. It is important that you have any intercepts graphed and any holes, and the other points are just to get the correct shape. Alright, so now that we have the graph in front of us, it's a little bit easier to consider the domain and range. So my domain is going to be from -infinity up until this asymptote, -infinity to -4. And then from the asymptote to the hole, because I also have to leave out the hole. So -4 until my hole has an x value of 6. And then 6 to infinity. When I look at the range, the asymptote is really close to the hole, but I'm actually going to still have 3 pieces. So I'm going to go -infinity up until my asymptote at 0. And then there's this tiny piece that's going to be between 0 and the hole that has a y value of 1/10. And then from that hole all the way up to positive infinity. The end behavior is going to be as x goes to infinity, y goes to the horizontal asymptote, which is 0 this time. And the same thing on the other side. As x goes to -infinity, y goes to the horizontal asymptote. Here you can see it. As x goes to infinity, the y is getting closer to this asymptote. And as x goes to -infinity, the y is getting closer to this asymptote. All right, let's go to the back. We have 2 more practice problems that involve factoring. This one, I'm looking for numbers that multiply to -6 and add to -1. Those numbers are going to be -3 and 2. And then the x squared comes from x times x. In the denominator, we have difference of squares, and those make a plus and minus pattern. One is just to remember, the first term is the square root of x squared, and the second term is the square root of 9. Another way to think of this is that we're looking for 2 numbers that multiply to -9, and since we don't have a middle number, they're going to add to 0. And it's still going to be 3 and -3. So again, we have factors that cancel out. They're going to create a whole. My simplified function is x plus 2 over x plus 3. My vertical, let me see, my whole first. Let's do the whole up here. My whole comes from x minus 3, the canceled out factor. I'm going to set it equal to 0, and I'm going to add 3 to both sides to get x equals 3. So that's the x coordinate. Substitute that back in here to find the y coordinate. So the y is going to be 3 plus 2 over 3 plus 3, which is 5, 6. Often there's a fraction for the whole. Not always, but a lot. Your vertical asymptote is what makes the remaining denominator equal 0. So for my vertical asymptote, I'm going to write x plus 3 equals 0, subtract the 3, and get x equals -3. Remember, you have to write the equation x equals -3, not just -3. Horizontal asymptote is different this time because they have the same degree. The biggest exponent on the top and the bottom is 1. When the exponents are the same, you take the ratio of the coefficients, and the coefficients are also 1. So 1 over 1 gives me 1, and horizontal asymptote always starts with y equals 1. We'll do these in a minute. We're going to do intercepts now. All right. To find your x-intercept, you're going to make y 0. So x-intercept 0 is the y, which is g of x in this case. 0 equals x plus 2 over x plus 3. But remember, when you have a fraction that equals 0, it's really just the top that equals 0. 0 over any bottom is still 0. So we can just write 0 equals x plus 2. Subtract the 2. And we get negative 2 equals x. So my x-intercept is negative 2, 0. For the y-intercept, we're going to make the x's 0. So y-intercept, y equals 0 plus 2 over 0 plus 3, which is 2/3. So that's going to be 0, 2/3. Okay, let's see what we have so far. Vertical asymptote at x equals negative 3. Horizontal asymptote at y equals 1. A hole at 3, 5, 6. So that's going to be down here actually. And then an x-intercept of negative 2, 0. And a y-intercept of 0, 2/3. So we actually have plenty of points for this branch over here. But I'm going to need some points for this branch. So I want to see what's happening when x is negative 4, negative 5, negative 6. So I'm going to graph this in my calculator. All right, so go to your y equals, clear out what's already in there. Remember to put parentheses around the top and the bottom. Here's your parentheses. Your X button is over here. I'm going to press graph. Okay, so it looks like so far I'm doing okay. I can't see the hole, but that's because the hole is actually infinitely small, so it doesn't show up real well. Anyway, but I didn't even graph the hole. I didn't graph the original function, so mine's not going to indicate a hole anyway. What I do want, though, is points on this branch over here, and so I'm going to press second table, and I want points before the asymptote, so I'm going to use negative 6, positive 1.3, and negative 4, 2. Negative 6, 1.3, and negative 4, 2. And that's just enough to get this sketched in. Okay, so for my domain, I need to leave out the asymptote and the hole. Start at negative infinity and go up to your asymptote here, which is at negative 3. Negative 3 up until the hole, which is at positive 3. And then 3 to infinity. My range starts down at negative infinity, and it's going to go to the hole. Negative infinity, and the hole has a y value of 5, 6. And from the hole to the asymptote, 5, 6, 1. And then from 1 to infinity. My end behavior is going to be the horizontal asymptote. As x goes to infinity, y goes to my horizontal asymptote, 1. As x goes to negative infinity, y is also going to go to my horizontal asymptote, which is at 1. Okay. Last one, looking at the graph, we can find a few things. We can guess that our vertical asymptote is happening right here because it's between the branches. And again, a horizontal asymptote is happening right here because it's between the branches. So my vertical is at x equals 4, and my horizontal is at y equals 1. My x-intercept is right here, so that's at 2, 0. And my y-intercept, I can't tell exactly where it is. It looks like it's about 0.5. I think it might be a little bit lower than 0.5, but 0.5 is a good guess. So that would be 0, 0.5. There's no hole in this graph. So in this graph, we only need to leave out our asymptotes. So for my domain, it's going to go from negative infinity until my vertical asymptote at 4. And then pick up right after that asymptote and go to infinity. My range is going to be negative infinity till my horizontal asymptote at 1, and then it's going to go from 1 up to infinity. My end behavior, as x goes to infinity, y goes to my horizontal asymptote, 1. As x goes to negative infinity, y goes to my horizontal asymptote, which is still 1.